Hi everyone, this is Mr. Cervone. Welcome to my math channel. For the do now, it says on a number line, what number is midway between -3 and 9? And what about between 4 and 12? So in order to solve this, you simply take the average. For example, let's call the first average to be x. So we take x equal to, and to find the average, you just take half the sum between -3 and 9. So we write -3 plus 9 divided by 2. So we end up with an x value to be equal to 3. So let's call y to be the average between 4 and 12. So y is equal to 4 plus 12 and then divided by 2, okay? So if we do the math here, we end up with 12 plus 4 is 16 divided by 2 is 8, okay? So there goes the answer for the do now. Let's plot these numbers, okay? So let's say that -3 and 9, let's call this actually to be our point x, okay? So x1, and I'm going to call this x2. And this I'm going to call y1 and y2. And let's plot this and see what we can deduce from this, okay? So here's the graph. So for point A, I called it point A here on the graph. That is -3, 4, okay? So in this case, we're taking the x1 and y1, so I'm plotting that, okay? And then for the second part, that's, or point B is 9, 12, and it will be here, right? 9 and 12. So I just plot them this way. As a matter of fact, what do you notice about this line segment that is different than in the do now? Obviously, we're superimposing here the x and y axis basically, okay? Because normally when you take the average between two numbers, you can think of it to be this on the number line, okay? For example, if let's say this is number line is x, then we have here somewhere a -3, and here we have a 9, and we found the average here, okay, which was 3, okay, that was the average. And similarly, if we call this number line to be equal to y, then we have here, we have a 4, and here we have a 12, and the average is exactly 12. Notice that the average means that the distance between each of the points and the average is actually the same, okay? From -3 to 3, we have 6 units. From 3 to 9, we have 6 units here. So it means we're adding 6. And similarly, to go from 4 to 8 and from 8 to 12, we add 4 respectively, okay? So what we're doing here is actually superimposing these two number lines, okay? We're going to leave the x over here, and then we place the y like this and plot these points basically, okay? So now what do you notice here, okay? You notice that if you plot the point 3, 8, it's exactly in the middle of the line, okay? And that is actually the midpoint. So now we can say that the midpoint here, the midpoint M, is equal to 3, 8. And you can see it on the graph, okay? So if I zoom in here, you can see that, you know, if this is 1 unit, this is 2 units, and 3 units. And you can see here that this is 8. You know, if you go over here, that is exactly at 3, 8, okay? And as a matter of fact, today, we are going to learn about midpoints of a line. How do you find the midpoint of any segment? And you kind of have an idea already, you know, from the do now, okay? That the midpoint is actually the average of the x and y coordinate. Is it always this way? And today we are going to prove it as well, okay? So let's first generalize this theorem. So the theorem states the following. Each coordinate of the midpoint of a line segment is equal to the average of the corresponding coordinates of the endpoints of the line segment. So what does that mean in terms of x and y? Well, let's generalize it. Given point A is x1, y1, and point B is x2, comma, y2, what is the midpoint of segment AB in terms of x1, x2, y1, and y2? Well, as we learned that the midpoint, according to the theorem, is actually the average of the corresponding coordinates of the endpoints of the line segment. Namely, the midpoint M is going to be the average between the x coordinates of A and B, which is x1 plus x2 divided by 2. And the y coordinate of the midpoint is going to be the average between the y coordinates of A and B, which is y1 plus y2 divided by 2. And this is also known as the midpoint formula. So basically, the theorem does a statement, but the theorem also generates a midpoint formula, as you can see here, okay? Okay, so this is a theorem. So let's prove it, that this is actually always true, okay? Okay, so for the proof, we're given a line segment AB with coordinates point A, x1, comma, y1, and point B, x2, comma, y2. And we're also given the midpoint of AB is M. The question is, or what we want to prove is the coordinates of midpoint M are x1 plus x2 over 2 and y1 plus y2 over 2. Okay, so how do we proceed with this proof? So the first thing is to draw a triangle ABC by drawing through A line parallel to the x-axis, and by drawing through point B a line parallel to the y-axis. And then you're going to let C be the point at which the two lines intersect, as shown in the graph here. Okay, so point C, where the two lines meet, is going to have coordinates of x2, comma, y1. And notice that the way we drew this is actually parallel to the x-axis, and this one is parallel to the y-axis, okay? So obviously, these two lines must be perpendicular, okay? So the next step is to find the midpoint between B and C. So I'm going to call this point D here, okay? And D is going to have a midpoint to be exactly at x2, comma, and we know the average between y1 and y2, right? It's just y1 plus y2 divided by 2, okay? So it is actually well known because here we're just dealing with a vertical line, so it's pretty simple to find the point exactly in the middle, okay? So now we're going to let point E be also the point exactly in the middle between A and C, okay? So E is going to have an x-coordinate, which is now the average between x1 and x2. So let me write this in. And it's going to have the same y-coordinate of y1, okay? So what do you notice here now? Well, we know that M is the midpoint, right? That's actually the given, that M is the midpoint of AB. And we know that E is the midpoint of AC, of segment AC. So if we join the midpoints here, then what can we say here? Well, then we can say that in this case, that segment EM has to be parallel to segment BC, which is parallel to the y-axis, okay? Now, what's the reason for that? So let's go back to postulational system, the second unit, when we learned about different theorems and postulates. So the theorem stated the following. A line that contains the midpoint of one side of a triangle and is parallel to another side passes through the midpoint of the third side, okay? Or the theorem can be actually rewritten that, you know, if you have a line that joins the midpoints of two sides of a triangle, then these two lines here have to be parallel. Namely, line MN has to be parallel to line BC, okay? If you think about this, this is actually kind of like rotated here. Okay, so you can think the triangle to be rotated this way, okay? This is MN. It's kind of like saying segment EM and segment BC. So, you know, therefore they have to be parallel, okay? Now, in a similar manner, we can connect midpoint D with midpoint M, okay? And again, now not only these two are parallel with the y-axis, but now we can say that, segment DM has to be parallel to segment AC, which is, parallel to the x-axis somewhere here, okay? So let me write this down, that in this case, we have DM parallel to segment AC parallel to the x-axis, okay? And that's basically the same reason. If the segment joining the midpoints of a triangle is drawn, then that segment must be parallel to the third side, okay? Now, why is it important to know that these segments are parallel? Well, because if they're parallel, then we know what the x and y coordinates are for the midpoint, okay? If you look at the x coordinate of M over here, that is going to be the same as the x coordinate of point E, correct? And similarly, so let me pick a different color here. Let's pick this one. The y coordinate of point M is going to be the same as this y coordinate over here, okay? And that's basically the proof here. So that means that the midpoint is going to be x1 plus x2 over 2, comma, and the y coordinate is just going to be y1 plus y2 over 2, and that's it, okay? And that's basically the proof here, okay? So let's see how we can apply the midpoint formula for an actual math problem in geometry, okay? So here's a problem. Find the equation of the perpendicular bisector of the segment AB determined by point A, 3, -2, and B, -1, 8. So how would you solve this problem? Well, imagine you have these 2 points, okay? Let's say point A is here and point B is somewhere here, okay? So this is segment AB. So the perpendicular bisector, as you remember, is defined as a line segment that is perpendicular to segment AB, okay? And goes exactly through the midpoint of segment AB, okay? So there are a few things we need to find here. First, we need to find the slopes, then the reciprocal of the slope because it's perpendicular, and the midpoint, and then define the equation, okay? So let's get into it. First, let's find the slope determined by segment AB, okay? And we learned this already, how to find the slope, okay? So we take the difference between the y values here. So 8 minus -2, and then we're writing -1 minus 3, okay? So that becomes 10 over -4, okay? So that simplifies to -5 over 2. So the slope of the perpendicular bisector, so I'm just going to call it M sub perpendicular, is going to be the negative reciprocal of -5/2, which is 2/5, okay? That means that the equation of the perpendicular bisector is going to be 2/5 x plus b. So how do we find the b value? Well, we need to find the midpoint first because this equation here goes through the midpoint M, okay? So the midpoint between A and B is going to be now the average of the x values. So it's going to be 3 plus -1 over 2, and the average of the y values, which is -2 plus 8 over 2, okay? Which is going to give us a midpoint of what? So let's do the math here. So 3 minus 1 is 2, okay? So divided by 2 is 1. And then we have here 6 over 2, which is 3. Okay, so now we have the midpoint and we have the equation here, okay? So what can we do at this point? Just substitute the coordinates of the midpoint in the perpendicular bisector equation. So here we have 3 is equals to 2/5 times 1 and then plus b. And now we just want to solve for the b value, okay? So let me rewrite this as over 5 so we can easily do the math here. So if this is over 5, then this should be 15 over 5, right? Is equals to 2/5 plus b, which means that b is equals to 15 over 5 minus 2 over 5, okay? Which is going to be equals to 13 over 5. So that means that the equation of the perpendicular bisector will have an equation as 2/5 x plus 13 over 5, okay? And that is basically the answer here, okay, for this problem. Okay, so that's basically it for today's lesson. Please email me if you have any questions. The homework is going to be from the Green Book, okay? So please check Schoology or Pupil Path. This homework assignment will be on Monday. The due date is on Monday. So again, thank you for watching and have a wonderful day.